Okay, so maybe we'll begin. Good morning, everyone, and thank you for joining today's HERC seminar. Today we have Dr. Robert Smith, who will present his work on methods from data science to improve the transparency and usability of health economic models. In terms of a brief background, Robert is a health economist based in Sheffield. His research specializes on the application of methods from statistical programming to health economics. And he has built economic models and user interfaces for a variety of different organizations. And these include places such as the World Health Organization, the UK's Joint Biosecurity Centre, now UKHSA, as well as top 10 pharmaceutical companies and charities. And he's also a co-director of the RHTA Consortium and part of the expert advisory group for the WHO Health Economic Assessment Tool. So without further ado, Robert, I will pass on control to you if you'd like to share your presentation. And so essentially, Robert will be giving 4 mini talks as part of the next 40 minutes. And so if you have questions, I would ask that you include them in the chat, and at the end of each one of the 4 talks, we'll have a short break, and then Robert can then address the questions. But if you could please hold off your questions until the end of each talk, that would be greatly appreciated. Okay, so Robert, over to you.
Just checking you can see the slide. That's great.
Yes.
So thank you very much, Marjan. That's great. And thanks for the invitation to come talk. We're just coming off the back of our HTA conference or workshop that was held Friday through Tuesday. So some of this will be familiar to those who were at that workshop. Other bits will be new. As Marjan just said, I'm gonna cover 4 kind of main topics. I'm going to try and keep it to about 10 minutes each, and then have some time for questions, just so I'm not talking continuously for 40 minutes with kind of no break. And I'm going to be talking today about improving the transparency and usability of health economic models. So it's polling day, so I'm going to intersperse some of these with pictures of dogs at polling stations, which I know always goes down well with everybody. Okay, so what is the overarching aim and kind of common topic amongst these 4 topics is trying to shift the modeling pipeline for analysis, modeling, and outputs from models to make it easier to update models, more transparent, and more efficient to work with models. So if you think of the current kind of HTA or public health modeling pipeline for a piece of analysis that feeds into a model, at the moment, I think we're generally up on the top diagram here, where you might do some analysis of some data. So it might be cost data or survival data. And you might do that in software like Stata, or you might already be using R. And then you might take the outputs of that. So there might be some parameters for a distribution, or they might be some average costs or utilities or whatever those outputs are, and you might then copy them into an Excel spreadsheet and include them as parameters in your model. You might then run your model, and potentially if you're doing things like probabilistic sensitivity analysis, you might use VBA, and then you might output the results of that model into graphs and tables in Excel, and then copy and paste those into, say, a Word document, and send that to a decision maker or other stakeholders. And then you might also copy and paste some of the graphs and tables into a presentation, which you then give that presentation to the same or different stakeholders. And so there's quite a lot of copy and paste going on here, room for human error, and also it's quite resource intensive. So those of you that are working in kind of the health economics space will know that there's a massive kind of demand for health economists that are able to build these models and review these models, and that's a problem. So being more efficient is kind of essential here. So what can we do and what can we move towards, well, basically I've been pushing over the last, I guess, 5 years to move more towards having a pipeline in which the whole system is essentially undertaken using script-based programming languages. Now, it doesn't have to be that that's R. There's other available: Python, Julia, C, etc. But R is kind of well placed given the kind of plethora of packages that are kind of built around survival analysis, biostats type work, and it also has some really good plotting, reporting, and user interface packages, which kind of make it very well placed as a programming language to do this type of work. And so that pipeline then might look like the diagram on the bottom here, where you might do your survival analysis in R. That then feeds directly into your model. The model is run using R, is output using visualization packages like ggplot. Those are fed directly into a report, for example, written in R Markdown, and you might want to display the model and be able to run the model live within meetings using the Shiny package. So it's essentially user interface to be able to run the model and change parameters live and see what the effect of that is. Now, what this means is that rather than copying and pasting as we're doing in the top kind of pipeline, we've now got a system where if data was updated or analysis was changed in some small way, we could click one button, rerun the whole pipeline, and have everything update. So there's no more kind of copying and pasting edits into reports. And users of a user interface know that they're always looking at the latest data. And so we presented this. This is from a slide that we presented to NICE, looking at Microsoft Excel versus R, and we posted this up online and got quite a good discussion going. And I think essentially the reason why we're working with Excel is primarily just because of its legacy in health economics. It's familiar to people. It's simple. You can kind of see with the Excel user interface what's going on, even if it's incredibly hard to kind of debug and understand going through a large number of cells. It's familiar to people, but its capabilities is quite limited, and we're moving to a situation where the models have got more and more complicated and require more and more computation. And so when we're doing things like value of information analysis or running probabilistic analysis, Excel's starting to fall flat, and we're getting to the stage where things are taking a long time to run. And so shifting to R is kind of helping with that. It also helps with kind of development and the way in which once people get well versed with the R programming language, it's much easier to develop and work together on projects using version control software. And it's also easier to make the code transparent, separate from the data. So to separate code and data and make code kind of available while keeping data secure. And finally, just the visualizations and things that come out of programming languages are much better. And you'll find now a lot of PhD students who might not even be using R for their analysis might translate some of the outputs into R just to get a nice visual. We're seeing that more and more. So the four topics I'm going to cover today, basically four related publications that I've been involved in over the last 5 years. So the first was called Making Health Economic Models Shiny, and that's probably the one that's got the most traction and most interest over the course of the last 5 years. And that's looking at kind of how we can build user interfaces for models and deploy models online so that they can be shared with stakeholders who aren't necessarily able or willing to kind of delve into the code and run things on say RStudio. And that's got a huge amount of traction, and I'll cover that first, and then look into Living HTA, which has got much less traction, but I think is still interesting and one definitely for the future. Essentially trying to automate updates to models as new data comes in, so that your model report always reflects the latest data. And then the third topic will be packaging cost effectiveness models, and this is much more kind of a bit nerdier topic, looking at how we build these models, the best way to build a model in R, and how we can make these kind of the ecosystem of algorithms within health economic models are easier to share amongst modelers. And the last topic, which is not published yet, but is in progress, and we presented this on Friday at our HTA, is an R package which is designed to improve quality assurance of health economic models by being able to look into the code and identify how the different algorithms of a health economic model fit together using network analysis. So starting with making health economic models shiny. So we published this paper back in 2020, and it's gained an incredible amount of engagement. Essentially, the logic behind this is that we have a model that we want to be able to share with stakeholders. Those stakeholders are not our programmers. They wouldn't be willing to open a console and play around with the code itself. So they might be politicians or clinicians or work for, say, an NGO. And so we want to be able to share this model in a way that's interactive and easy to use. And these might be people that otherwise we would have tried to send a Excel file to them and then potentially had to kind of go through that live with them. And so the idea is here, can we take the model, deploy it on a remote server, and then have a user interface, so essentially a website, so that the user can play around with the inputs and understand the effect that those inputs have on outputs. And the key motivation here really is that quite often at the moment, we'll be writing a single report for a stakeholder, and that report will be submitted. And we saw this during the pandemic. We've seen this in a number of instances where you can often lose people with a single parameter. So it might be the case that we've made some assumption in our model, and the reader of our modeling report gets to that page or looks at the parameters table and says, I disagree with this, and therefore essentially the report goes in the bin. And we do obviously, of course, do one-way sensitivity analyses and all of that kind of thing, but it's much easier to engage people with the model itself when you give them control and say, okay, so what if we change this parameter to this new value, which you believe is better? What does that do to the outputs? And it gives a much more detailed understanding of the model itself. And so we're kind of giving power back to the stakeholders to be able to interrogate the model themselves rather than kind of read the report that we've written. And we found that this can be much more engaging for users. The benefit of this as well, so there's a secondary benefit, and that's certainly the primary benefit, is just engaging users of the model and allowing them to play and interact with the model in such a way that they feel like they have ownership over it, rather than a written report where we're kind of telling them the result. A secondary benefit is once we move towards these models that are deployed on remote servers, we can run this code much faster. And so models that in Excel might take hours can take seconds online. So we've deployed, and there's a link here which I can go through after the questions or at the end of the session. Essentially, we've deployed a model online as a prototype, which essentially it runs a time-dependent state cohort transition model, and it runs that for 1,000 PSA iterations in about 5 seconds. And so this is just a lot more kind of computationally powerful. And so something that before couldn't be done within a meeting now can be done on the fly in a meeting. We can say, so what if we want to use a different fit for a survival analysis? Let's change it, let's rerun our model, and let's see the results. And therefore that it's not a case of having to go away and sort of redo analysis and rewrite a report and then come back weeks later. It's a case of, okay, so we've changed some assumption, rerun, here's the new results. We can carry on with our discussion. And quite often people are surprised that actually it doesn't change the outcome. And so that can be really useful, even if the parameter that people thought was really important isn't. That's really useful in itself and then the discussions can continue rather than kind of analysis being redone and wasting a lot of time. So we built a large number of these now. So we built an app with York for distributional cost effectiveness analysis, the prototype apps, apps for shortfall, and then a large number of apps that are kind of not openly available for kind of variety of stakeholders, ERGs, farm companies, WHO, and then and so one example is an interface which allowed a stakeholder to play around with a model that was built by an ERG. And what that meant is that stakeholder, previously this would have been, 5,000 lines of code that was shared on GitHub and completely inaccessible to that individual. Now they're able to log on to a website, enter a password, go into the app, change a few parameters and try and understand how the model works. And what this meant was that they were playing around with one of the parameters in the model, and it wasn't changing the results as much as they thought. And they were very surprised by this. And so they said, why is this not really having much effect? And we looked into the code and found a bug. And so that's an example where that stakeholder otherwise wouldn't have been able to engage and would have just had the report. But because they were able to engage with the model, even if they weren't looking directly at the code, they were able to engage with the model on the top level. They were able to then play around with the parameters and try and understand the sensitivities. So probably the most valuable time I've seen this used is when working at the Joint Biosecurity Centre, now UKHSA, where we built simplified models, SER models with different variants, imports, different populations, different vaccination states, and cross protection. And these models, as I'm sure a lot of you know, are incredibly complicated. And the models that were built by the large universities, so Warwick, Imperial, and London School of Hygiene and Tropical Medicine in particular, took hours or days to run. And so we built a simplified version of that model, which allowed users to play around with those parameters live and rerun. And so it wasn't necessarily the model that was kind of the final report that was kind of included as the final decision-making model, but it was a model that allowed us to understand and allowed stakeholders to understand kind of what are the key parameters that are driving the results and the outcomes here. But there is a danger with this, and the biggest danger I've seen with these user interfaces, having spent the last 5 years building a huge number of them, is that people do tend to get very obsessed with the kind of visual component. And so while it does empower people to use the model in a more interactive way, it's also kind of quite flashy and probably a bit more artistic as an output than our kind of typical modeling and modeling reports. And so there's a kind of can be a bit of an obsession in having a really fancy looking app and distracting from actually a very well constructed model. So it's probably a bit of a warning for those that are interested in building these applications. So I'll really pause there and take any questions at this stage.
There are no questions in the chat. I'm wondering if anybody has a question. If not, we could move. Oh, Helen, sorry. Helen, go ahead.
I was just going to ask how long would it take the average reasonably good R programmer to kind of make an R Shiny model if once they've already got a model there?
Yeah, so once you've already got your model built in R, you can it's one of those things where you can build a very simple application very, very quickly. So you're talking maybe a day or two to get something incredibly simple out, to build something that looks very professional and guides kind of users through the important parameters. It takes a lot more thinking and conceptualization than people realize. So it's one of those things where to build something really quick and dirty is quicker than people think. To build something that's actually good is it is a lot slower than people think. So we've had times where I've kind of built the user interface in a couple of days. We've had other times where we've spent longer on the user interface than we did on the model. So it really does vary. But just to show how this works and how quick this is, so we can run this analysis live. I've just chosen the default parameters for all these different inputs, and that took 8 seconds there to run. And then we get our kind of ISA table, cost effectiveness plane output, SEAC, all the normal things, and we can download an automated report, slide deck, Word document, or email results to stakeholders that we want to live, showing the different parameters we've chosen. So here we've got like our baseline survival, which model fit to use, all of those kind of things, all in the application, which is really useful and powerful for people.
Jose?
Hi, Robert. It's very interesting. I just wanted to hear your thoughts about the use of R, for example, or even state for models that are more complex, like the UKPDS, for example, outcomes model, or any microsimulation model with several equations that forces to use C++ to have something that can be run within reasonable time. So the question is if we're going towards models that are more complex, do you see R as actually being a useful tool, or eventually we all migrate to programming like C++, and with that kind of programming, then it becomes, I guess, harder to validate a model?
Yeah, that's a really good question. So we've just come off of teaching a course in efficient microsimulation in R, so it's very much that topic. And what we find is that it's very, very slow to develop a model in C++. It takes a long time because you're having to explicitly define all your parameter types and all of that kind of thing. Whereas coding in R is much faster, but C++ is much faster to execute. And so what we've recommended and tended to recommend is that you build the model in R, you construct it in such a way that it's made up of a series of functions, which I'll cover in a minute, and then you locate the functions that are taking all the time to run. So in the example user interface I just went through, it's a time-dependent Markov model, and there's a loop in there where you're calculating the next the proportions in each health state in the next period, and that's the bit that takes all the time in the model. So we rewrote that in C++, and then loaded it in from GitHub within the server side of the model, and then rerun the model. So it's an R model that calls C++ to do the bit that's slow. And that is kind of that nice trade-off then between a fast development process. It's really fast to build a model in R, but then making the most of C++ and the speed that you gain from that in computation time. So that's what we've tended to recommend so far.
Our experience, just to add to that, has been to build, for example, in Stata, and then provide the code to programmers to do it in C++, because it's out of our area, because we find it very hard to compete in terms of speed. But yeah, it's very useful to hear.
And just before you move on, there's one last question in the group chat, Robert. Are there any license restrictions? What is the cost of R Shiny?
So R Shiny is free. Almost everything on R is open source. Well, it's all open source and it's almost all free. There are some packages, so there's some visualization packages which you would have to pay a license fee to use, but there's almost always an alternative one that, so for example, like ggplot or gganimate are free, but then there's the highlighter package, which has some really cool extra visualizations, but you have to buy a license. So yeah, like almost everything we do, we just do with the free version, and it generally looks great and feels very professional. So yeah, completely free.
Great, thank you. Feel free to move on to the next talk.
Okay, so I'm conscious on time, so I'll go through this one maybe a little bit quicker. In part because this is also getting way less traction than the Shiny user interfaces, and that's the topic of living HTA. So we published a couple of papers in 2022, 2023, looking at living health technology assessment and the potential to have models which are kind of updating as new data comes in. And we were looking at the whole, all of the steps of kind of HTA, from searching, literature reviewing, meta-analysis, cost-effectiveness modeling, and reporting. And the kind of the aim here is to look at and see, well, the aim of the paper was to look at, kind of where are we in terms of moving towards a living health technology assessment framework. And each one of these areas has a whole kind of body of research and companies, universities working on finding ways to essentially automate the process of literature review, data extraction, meta-analysis, for example, and cost-effectiveness modeling. We've been much more involved in the cost-effectiveness modeling space, but in that way, where we've kind of been most kind of focused is how can you automate updates to health economic evaluation models using R, GitHub Actions, R Markdown. And we actually did two things in this paper, which I think was a mistake. So the first was looking at, okay, how do you update a report as new data comes in? And the way we did this was to trigger automated workflows when data sets change. So you have a data set, say, of trial data or of costs or utilities, or whatever the data is that you need. And when that data, anytime that data updates, it triggers an automated workflow in which the model is run on that data and a report is generated. So there's nothing kind of too novel there. The tricky bit was then to say, okay, so that data is often going to be very sensitive, and users are not going to want to provide access to that data to anybody. And so how do we do this in such a way that, say, pharmaceutical companies or government can have models that update and reports are generated without necessarily having to share that data? And so what we essentially built was this system where rather than data being sent to the model was sent to the data. And so we have essentially a model package or model code base that's on GitHub, and the company set up an API which, when their data updates, it goes and grabs the model from GitHub, it loads that model on their servers, runs the model on their data, and returns the report out. And so what this means is that they're not having to share their data with any third parties. And so we built a prototype of this that was fully functioning, and essentially, yeah, it means that you're not having to share data backward and forward every time data's updating, and no data actually ever leaves the company's servers. Where this is very tricky is that it needs then somebody on the company side to set this up, and so that's where we've faced barriers and difficulties. So this, of all the topics, this is definitely the one that's gained the least traction, except the concept of kind of having automated updates to reports, which was used during the pandemic, and has been is kind of, we're in discussions with colleagues from Australia and Canada in setting these systems up, especially where data is updated very frequently. So there tends to be a lot of stuff in government using sort of health sources from hospitals and other sources. And so, yeah, we built this prototype. You can find it online. We've not kind of maintained it longer term. But essentially what's happening here is that the user's entering their password to connect to the API. And then we built a user interface so that they can run the model with any parameters they want to run them with. But what's useful here is that actually the model, the data itself is not being stored on a remote server. It's being stored on a company server. So they've not had to relinquish access to their data, which is obviously definitely a concern for a lot of pharmaceutical companies and universities. It's a much quicker topic. I don't know if there's any questions on that.
There is a question in the chat from Matthew Little. You mentioned a client finding a bug in a model. Does this workflow make QC easier? And doesn't more moving parts make a mistake more likely?
So this workflow in terms of living HTA and having the code separate from the data, I personally think makes it much more robust, because you can. So in this case, for example, the model code is stored open access on GitHub, so anybody could go and look at this code. And so there's a lot of value to making things fully transparent and having the light of day on them, which then means that you're much more likely to spot bugs and errors. So here, for example, we could have an expert who wouldn't necessarily even need access to the report or to the data, but could just look at the code with some example data and run that and analyze that. And you can have members of the public. I mean, we saw this during the pandemic. We had members of the public who were very keen to kind of understand and analyze and kind of look at the data. And so sometimes there's a danger that we build a model, we send it to, say, an ERG or a group from a university, and it's reviewed once, and then decisions that are worth, you know, millions or billions of pounds are made based upon that report that has been reviewed by, you know, potentially 3 or 4 people in detail. Whereas being able to share the code completely separate from the data and all the sensitive modeling stuff is really valuable. And I appreciate there's intellectual property concerns about, you know, the code itself has intellectual property concerns. But I think if we can get to a space where we're making things more transparent, that's got to be a good thing.
Couple more questions in the chat. Helen, did you want to unmute yourself, or otherwise I can?
It was more of a comment that I don't know how NICE would have kind of incentivize companies to provide updated data once the drug has been approved by NICE or is on the Cancer Drugs Fund. It's hard to say, unless it's like some condition of an only in research recommendation. It's hard to see what incentive the company would have to provide updated data.
Yeah, that's a good point. And so where this concept has come from was during the pandemic, when the evidence base was changing so quickly, because we didn't know, you know, we didn't know for a lot of the parameters, there just wasn't a large body of evidence, and then that was gradually improving over time. So where I'd probably see this being used the most is not necessarily for the company trial data, but for, say, a meta-analysis of published studies. So where a new study is published, we could then update the meta-analysis, and that feeds then back into the model. We might also have situations where we're kind of looking at real-world evidence. So rather than say trial data that has to be provided by the company, we're just looking actually at what's observed from, say, hospitals or yeah, it depends on the topic. This isn't necessarily always kind of a HTA method so much as a method by which we can update health economic models that might not be for drugs. It might be public health interventions. It might be, you know, other things. So.
And one last question before you move on, from RJ: is there any concern that the sensitive data can be exfiltrated?
Yeah, that's a massive concern. So we wrote a load of tests into the prototype, basically to say, essentially search for any of the sensitive data, and try and identify that. But this is something that's raised a lot. I think one of the ways to avoid this is to have. So what we've done here is we've written this in such a way that the model is on GitHub on a specific repository location, and that so when data updates, the workflow process is to go and grab the model code from GitHub. Now that GitHub repository could also be owned by the company, and the consultant or whoever was building and adapting the model could then have to submit a pull request into the company. So you'd literally be able to see, you know, who updated that. Well, first of all, any updates to the model would need to be approved, and secondly, you'd be able to see who updated that code and when. also, I mean, the current system, right, is that the data quite often is being shared, like, or the model is being shared via email, which, I mean, you've completely lost control of it then. So I suppose it's kind of what's the current system and which is more secure. Yeah.
Thank you.
Okay, but yeah, that's certainly gained less traction. It'd be interesting to see as whether there's increased acceptance of that living HTA type work. I personally think it's really interesting, as it would allow us to make kind of more routine and regular decisions, and also to follow up with real world evidence and say, okay, so essentially more regular updates to models and modeling reports. But we'll see how that goes. The next topic is much more kind of at the level of the model and trying to understand the model and how we construct these models in R. So for those of you that are not R programmers, it might be kind of a new topic. But if we imagine that our model in R is a series of a set of inputs, and then we have our model, and that's a set of results, and then that gives us a set of results. And what's actually going on is we have a load of documentation, some raw data, we have all of our functions and our user inputs, and they're all have to be stored somewhere. And then we have our model, and all that information is passed through to our model. And then our model is just a series of algorithms, which are functions, which may be sequential or nested. And all of those processes are kind of worked through in our model, and then we get our results come out. And so those might be in the format of a data frame, a table, some figures, and some plots and tables, that kind of thing. And so when we look at our file structure in R, what this actually tends to look like for models is you'd have a folder that contains some data, you'd have a folder that contains your functions, you'd have a folder that contains your documentation, and you should, in theory, at least have a folder that contains your tests. And then you may have a folder that contains the outputs, or you may not, and then allow the user to run the model and generate that folder that contains the outputs themselves. And so people building R models in this structure, which kind of tends to be the most common structure for a model, essentially my argument is that you may as well just build your own R package, because essentially once you have all this stuff, you basically have the structure of a package anyway. And so this is the package structure. So the functions are contained in the R folder, documentation is contained in the man folder, data is contained in the data folder. You can have vignettes, which include documentation, and unit tests in the test folder. And the benefit of this is that non-packaged code kind of is more flexible. That's true, but every package has kind of a similar structure, and it encourages people to document what they're doing, to include vignettes of how these different functions and model fit together. And by default, you can kind of essentially test that you have the necessary documentation for each function. Unit testing tends to be built in, so unit testing being tests on each function that are included in the model. And pretty most importantly, at the kind of top level, why is this useful is that functions are much more easily distributed. So you can just do install.github or install.package, and then you immediately have the functions that you need from that model. And so you might imagine that we have a code base, and for the first model that we build, that contributes quite a lot of code. Well, everything is new, everything is novel in terms of the code base. But the second model we build can use a lot of the code from model one, a lot of the functions. Imagine that every model might do some discounting, and so we don't all need to write the same discount function. We can just use the discount function from model one, and model 3 might use some of the code from model 2 and model 1, and then so on and so on, so that each model is kind of using less novel code and more kind of previously created code from previous models. And this is kind of being done anyway, but just in copy paste format rather than just installing those models. And so, but the problem with this is that we're having to install a large number of packages with previous models, just to get one or two functions from each. And so what kind of calling for is a industry, academia, and consulting kind of collaboration to take from these different models the useful functions, so that we're not all kind of reinventing the wheel and writing our own function to, for example, discount or calculate expected life years or whatever, and then have a regulator say, we prefer that you use this package because it makes it easier for us to review it. Because if you're using the discount function from this package, we can trust that that's correct because we've reviewed that on previous models. And so the idea is that then users for model 7, 8, 9 can just use the functions from that regulator preferred R package. And there are discussions ongoing about how to implement this. And those, of course, would feed back into this process. And so then that regulator preferred package gets slightly bigger with more functions. And then that process continues. And so I guess the question is who is best placed to do that work? And there's a consortium of health economists working in this space who are kind of essentially applying for funding to do exactly this. And so the idea is that these packages can basically be templates. They make it easier to review and distribute code, but confidence is crucial. And so if we think about, I guess probably the most important takeaway from this is just how little of most models is truly novel, and how much is just recycled from previous work. And so from a reviewer perspective, it's much easier if we know that we're using a function that's previously been reviewed by experts in that field. We've got a lot more confidence in that function than if we're having to review a function that has been created bespoke for this model. And so there are previous examples of building these models in packages. So the CDX2 biomarker testing model was built in an R package by Fernando over at Stanford. And this was built in such a way that you could just install a package, the CDX2 CEA model. And so then if you wanted to use one of the algorithms for that model in your own model, it's very simple. It's one line of code and then use the function, rather than having to kind of rewrite your own function or copy and paste from his code. So that's super useful. And there's others that are now building their models in this structure as well. So let me pause there.
Are there any questions for Robert? If not, we can move on to the last part.
Okay, so the last topic is reviewing health economic models in R, and this is the thing that I'm currently spending most of my time sort of working on from a research perspective, and we presented it on Friday at RHTA. So I think we've covered throughout that there's going to be different users of a model and different reviewers of a model. So again, this is from a presentation to NICE, where we're looking at kind of who might use different models. So you might have reviewer number 1 who has access to everything here. So they might be interested in the source code, openly available data, but they might have access to sensitive data. So this might be someone like a ERG or someone from NICE who really needs everything. They won't need to understand the sensitive data, how it all fits together for the report. But other people might just be interested in some in looking at the source code and what's going on in the model. They don't necessarily need access to the sensitive data, and so having that code separated from the data can be super valuable. And finally, another reviewer. So this might be someone who's just a stakeholder who's not necessarily interested in the modeling process or the code, but they're just interested in kind of what's been used to come to the decision and the sensitivities of different parameters in the model. They might be interested just in using a graphical user interface to interact with the model. So there's kind of different needs for different people. But for those who are actually kind of building, so I guess reviewer 1 and reviewer 2, we have tried to develop this package in R. We have developed a package in R essentially to try and help modelers build and review health economic models in R. And there's kind of two core bits of functionality. The first bit is to check that the objects created in the models conform to standard rules. So this is really basic stuff like does your transition probability matrix, do the rows are the rows between are the values between 0 and 1, do the rows sum to 1, all of that kind of thing. But it's the kind of thing that we're all building into our models ourselves. Whereas if you just have a function from a package, you can just load that package, call that function, and you're not having to write code to do all these checks inside of your own model. And also for reviewers, they can just review and again use this package. And that's kind of interesting and useful from a kind of efficiency point of view. But then the second one is probably the one that I'm most interested in, and people have definitely engaged with more, which is being able to summarize and visualize the structure of a model. So I said in the earlier topic on the packages that the model is just a series of algorithms that are either sequential or nested, and being able to understand how those fit together, it can be quite tricky. And so we built a tool to enable people to do that. So here's the two different use cases. So on the left here, we've got how to insert checks into the code. So this is a check trans prob array, which basically is just writing a check for a three-dimensional time-dependent transition probability array to make sure that it's complying with different rules, and then flagging where there's potential errors. But then kind of the more interesting topic is how to visualize the network of functions within an R model. And so we have this function visualize project, which basically allows you to pass through the project path, where all the functions are, where all the tests are, and then inspect the network of functions to see how all the different functions of the model fit together. So yeah, so there's a number of checks, and we're kind of increasing the number of checks. And this actually is really valuable, really useful, but it's not super exciting. The more interesting thing is this network visualizer. So the way this works is to look through the code and see which functions call which other functions, and then to produce a network diagram. So here we've got our simple teaching model, Six Sigma model, and there's a function run Six Sigma model which runs the whole model. But then there's these functions which occur sequentially within that model. So creating a Markov trace, calculating the costs, calculating the qualies, all of those kind of things. And you can see each one of those is called by the run Six Sigma model. And so these nodes are green where there's a test associated with the function. So test to make sure the function is operating as intended. Or they're yellow where the coverage of that test is between 20 and 80%, and they're red where there's no test. And so that's kind of the logic behind the colors there. But what's nice is that the way we built this is that if you click on one of the nodes, you get this little pop-up which tells you the function name, where the function is located in the code base, and you can click on the I symbol to see the function code. So here we can see this function is included in the R folder, and then this file, create Markov trace.r, and it's defined on line 45. So you can very quickly get to that function, and you can either visualize it in the in this app that pops up, or you can click this button and that takes you to RStudio to that location. And we can see where the corresponding tests for the function live, which is useful. So we can go over and say, how many tests has this modeler created, and I can review those tests and say, are these tests extensive? Is this function actually doing what they say it's doing? Am I happy with the test? Do I need to write more tests? All of that kind of thing. But we can also add in our own functions to this network, and we found this useful when we are building our own models. So as a project team, we can then say, okay, so we've got this this model, but actually we want to build in a new function here to do this thing. And so then having a visual representation of where that function sits within the network of the model is quite valuable. Otherwise, sometimes it's quite tricky to define exactly what's going to go where as we adapt a model. And then the last thing, which has got a huge amount of interest given the kind of hype over AI at the moment, is that we've built in the functionality to be able to generate a large language model summary of a function from this user interface. So essentially what it does is when so the way in which the code works is that we understand, or we have the network of all of the functions. So the network here, which is a very simple network, but we also have data for each function. So that includes what are the arguments of the function, the body of the function, the documentation around the function, and what other functions call it, and also the children and the parents of the function in this network. And so we can pass all that information in a kind of structured way in a prompt to OpenAI's GPT 3.5 and ask it to summarize the function in layperson terms in 2 paragraphs. And so we extract the function data, create the prompt, send the prompt to a GPT via API. So from the user's perspective, they don't see any of this. They just click a button and it all appears. We receive the response back from the API. We reformat the test, and then we show the response in the modal. And this whole process takes about 2 to 3 seconds. And so then you get, from clicking that button, you then get something like this, which just gives you a 2 paragraph summary of what that function is doing. And so while it's not always perfect, it allows someone who wants to very quickly understand a model to look and visually represent that model and say, okay, so here's how all the functions sit together, and this is what each function is doing in a very quick layperson summary. And so we've applied this with a huge amount of interest in this. So we applied it in a few different cases. And we're requesting that people provide more to us. The code is all open source. So some people have been either sending their model or links to the model code to us and saying, can you run it on that? Or they've been just trialing out the Assert HE package themselves on their own code internally. So these are the ones that are open. Most of these are open source. But I think we've tested on maybe 10 to 12 models now, and it's gradually improving. So this is the CDX2CA model. That's not too complicated a model. This is the micro simulation from Sheffield, so the diabetes model at Sheffield, and you can see how complicated this is, but being able to visualize how these different algorithms fit together will be really useful. And this is the NICE RCC pilot, and it's a massive model with a lot of the kind of nested functions that are kind of hard to disentangle sometimes. And so in terms of next steps on this, conscious of time, but in terms of next steps, we want to welcome people to try out this functionality on their own models. And we're trying to use some of our teaching materials. So we run a whole series of courses and have a course book of about 13 chapters on different topics in using R for health economic evaluation. And so we want to fine tune the large language model using this teaching material to then hopefully improve its performance in, say, recognizing what different object names, for example, are. And we intend to submit this to CRAN in late 2024, and continue to collaborate. So completely open source. If you want to have a look at the link, feel free. And there'll be an open access publication, which we're currently drafting, but that will be out soon.
Great, thank you so much, Robert. I see some hands up. Helen, I think yours was first.
I was just going to ask, will that function work on any model in principle? It doesn't have to be built in a particular way.
So the only requirement is that there is a folder somewhere that contains all the model functions. Other than that, it should work. So if you were to write your entire model in a single script with no functions, there would be no network to show, because it's only showing the network of parent and child functions. But as long as you have functions in your model, it will visually represent how those functions fit together.
But if all the functions are in one file, it won't work.
No, it'll still work as long as the functions are defined somewhere.
Okay, yeah, they're all in one script. Cool.
Yeah, but if you have one script that uses no functions, so if your model doesn't actually call a function, it just like does everything line by line and doesn't define any functions anywhere, then there'll be no functions to summarize. But
Cool.
as long as you have functions in your model, you should be able to use it.
Fantastic.
Oliver?
Thanks, Robert. Very interesting and engaging presentation. Related to Helen's comment, R releases new versions 3 to 4 times a year, and how dependent may be these in terms of operating with the most updated version and going back to previous versions of R, for example.
Yeah, so that won't make any difference to this. It will. So essentially, what all of these functions that are here in this network are custom built functions by the modelers. And so as long as the way it works is essentially the assert HE package function trawls through the code base and identifies where a function is defined, and then grabs the body of that function, and then looks at which functions that function calls, and then constructs a network diagram. So it's completely separate to kind of the R, the version of R you're running or anything like that. So it should work fine. So we've had people test it with who are using different versions of R, different external packages, all that kind of thing, and it's always seemed to work. What tends to break it is the code. Like if there are errors in the code somewhere, that mean that the code can't run itself. So we've one example is we couldn't in this CDX2 CEA package, we couldn't actually include code coverage. We could only do the network of whether there's a test or not, but not the code coverage, because the some of the tests that were built into it broke when they were run. So this is an issue with this package. But yeah, it's kind of, I guess if the code on your model returns errors, then there's not too much we can do about that.
Thank you.
Okay, and one last question in the chat. Could the addition of a function in the network visualization also use a large language model to generate a skeleton of code from a short description of what the new function does? And this could help new R programmer approach a new model with more ease.
Yeah, that's a really good question. So we're looking at, so there's two related things. So one is, can you take so in this example, say I want to add a new function, could I then produce a 2-paragraph summary and get the GPT to write the function for me? We've looked into this. This is incredibly tricky to do. And the GPT, in my opinion, is still a ways off being really reliable on this. Where we think we can be useful is I'm pretty sure we can ask it to write a test for a function that already exists. So we might say there isn't a test for calculate costs, but I'm going to ask the GPT to write me some tests. And because we can pass it all of the information about calculate costs, it should be pretty good at writing tests for that. So that's probably our next step for us. If we could get to a situation where we were able to get GPT to write really reliable functions to build into models, that would be great. But I personally think, when we had a discussion about this in a panel on Tuesday, I think you have to be really careful because of the human error associated, like how tightly you have to define everything. Essentially means that you'd be quicker just doing it yourself.
Okay. Well, we're at time and I don't see any more hands or questions, so we could conclude here. Thank you all for attending and for participating, and a really big thank you to Robert for those terrific presentations on making health economic models more transparent and usable.
Thank you very much.